All right, everyone. Today we're going to cover 2.8 inverse functions, and I want to start by going over the definition of inverse functions. So, inverse functions. Let f and g just be two functions. You might remember from the last lesson, composition of functions, f of g of x, and if we go backwards, g of f of x, right? Well, if we do those composition of functions and we get x in both of those, that means that both f and g will be inverses of each other. Note, the inverse of the inverse function f is denoted as f to the power of -1, but is read as f inverse. So if we were to do the f of f inverse of x, we would also get x. And if we were to do the f inverse of f of x, we should also get x. All right, so let's look at a couple of examples so we can piece this together. And we'll start off with showing that each function is the inverse of the other. So we start with f of x and g of x. Remember that in order for them to be inverses, we should get f of g of x, and it should give us x, right? And we should also do, oops, I was going to write the same thing. We should also do g of f of x, and it should also give us x, all right? So let's start by doing this thing here on the left side. Let's start by plugging in g of x. Well, if I plug in g of x, it's going to be x minus 2 over 3. And if I plug that into the f function, I'm going to be plugging that in right here. So that's going to give me 3. Let's multiply by this x minus 2 over 3. And we want to do the plus 2. All right, so this 3 is being multiplied by all of this, but more importantly, the 3 on the top and the 3 on the bottom, we can just get rid of those. All right, so we were left with x minus 2 plus 2, which we can also get rid of these, and you can see here that we're definitely left with x. Now, it is possible to get x on one of these and not on the other. Remember that you have to do both of them. They should both give you x. All right, so now we'll try to plug in f of x. If we plug in f of x here, we get 3x plus 2, and we want to plug this in to the g function, which is right up here, okay? So we're going to get 3x plus 2 getting plugged in there, and then minus 2, and then all of that has to get divided by 3. So I'm going to do some simplifying in the numerator. I know that 2 minus 2 is going to cancel, leaving me with just 3x over 3. I know that these 3's cancel, and you can see here we're simply left with x. So what does that tell me? It tells me that f and g are inverses of each other. All right, let's do it again. This time, we just are going to determine if f and g are inverses. So we're going to do the same thing, okay? I'm going to start by taking f of g of x, and I also want to do g of f of x. All right, so I'm going to start with this one. This means that I want to take g of x and plug it in. So this is 1/2 of x plus 3 over 2. All right, now another way to write this, by the way, since you notice that there's a common denominator, 1 times x, that's really just x. And you can also write this as x plus 3 over 2. You might like that better. That might look a little nicer. In fact, it might even look like the last question that we did. Is it necessary? No, but it's a little easier on the eyes, right? Because now we're going to plug in f into there. So what does that look like? Well, I'm going to plug this craziness into this f function right there. So this is really 2 times 1/2 of x plus 3 over 2, right? I'm just plugging in my x value there. And then I got to do minus 3. So what happens here is that we want to distribute this 2. But also 2 on the top, 2 on the bottom. We're going to cancel those out. Just x, right? Same thing here. 2 on the top, 2 on the bottom. Those are going to cancel out, leaving us with just 3. And that's where writing it like that on the top here really could help us out a little bit. It's not a deal breaker, but, you know, it might be a little easier on the eyes. Okay, 3 minus 3, we get rid of those, and we are just left with x. All right, looking good. Now let's take the f of x and plug that in. What's f of x? This guy, 2x minus 3. Where are we plugging that into? We are plugging it into the g function, right? Okay, so 2x minus 3 gets plugged into here, right in for x. Or if you rewrote it, you can plug it in there, and it looks a little nicer, right? Okay, I'm going to keep the original version because most students will keep it like that. So this is half of, let's put here 2x minus 3, and then plus 3 over 2. Okay, you can definitely see here, this looked way nicer. But what do we do with this 1/2? We're just going to distribute it. All right, so this 1/2 just gets distributed, and half of 2 is just 1. So that leaves me, or 2 on the top, 2 on the bottom, right? It leaves me with just x. All right, but then here, well, what's half of negative 3? And that's going to be minus 3 over 2. What do we have next? Positive 3 over 2. We can certainly cancel those out, and we are left with x. And what does that mean? The question was determine if f and g are inverses. I would say yes, f and g are inverses, right? So yes, you can say f and g are inverses. If there's more than just two functions, let's say there's an h of x function, then you have to be explicit in your answer, and you have to write f and g are inverses. Okay, so let's go and review something that we've seen before. You should have seen this in Algebra 1, and you should have seen this in Algebra 2. But how do we find the inverse function? So these are just a couple of steps. Feel free to read them as we go through this question. Finding the inverse function. First thing I'm going to do here is I'm going to swap this out for y. So this is y equals 7x minus 5. Now I'm going to swap out my variables. So this is really going to be x equals 7y minus 5. Okay, and then now I want to solve for y. So I want to add 5 to both sides here. This is going to cancel. We're going to get x plus 5, which is going to equal to 7y. And if we divide both sides by 7, we're going to get that y is equals to this. So we've just solved for y. Now, in any question where you're starting with f of x, it's a really good idea to replace the y for f of x. And remember that what we just did here, the swapping process and the swapping idea for the variables, means that you're doing an inverse. All right, so that means that we just found the inverse of the f of x function. So f inverse, all right? And what is that inverse? This thing, x plus 5 over 7, all right? Which basically means that if I wanted to take my f function and plug in my inverse, I should get x, all right? So that's actually kind of cool. All right, so this is how we write it when we start with f of x, okay? Most of the time in this class, we will be starting with f of x. All right, let's do a couple more. Finding the inverse here. I'm going to start by replacing my f of x for y, which means I'll get x cubed plus 1 over here. And next, I'm going to swap out these variables. So x equals y cubed plus 1. And now, I just want to isolate y. So I'm going to start by doing a minus 1 on both sides. And that'll give me y cubed, which is equals to x minus 1. All right. Now, how do I get rid of a cube? I'm going to just take the cube root. All right. And I should do that on both sides. So this cube and this cube root, we get rid of those. Leaves us with y, right? Which is the cube root of x minus 1. Since we obtained y, go back and double check your question. Well, we started with function notation, which means we're going to go ahead and write f inverse of x is in fact going to be equals to, let's write here the cube root of x minus 1. All right, that's our inverse function right there. Hopefully that's not too bad. The questions do tend to get more difficult sometimes, but not always, okay? So let's try a couple more. This is going to be y equals, we got 5 over x plus 4, and we're going to swap out our variables. So x equals 5 over y plus 4, and then now we'll just move this 4 to the other side. Our goal is to isolate y, right? So I'm going to do minus 4 here, and I'm going to do minus 4 here, and that's going to leave me with 5 over y, which is equals to x minus 4. And you'll never be able to solve for a variable if it's in the denominator. And since we want to solve for y, let's get it out of the denominator, okay? I'm going to go ahead and multiply y to this side, which means I'm going to have to multiply y to this side. Now, I don't want to write it like this, because then the only thing getting multiplied is x. The thing that was on the left side originally was x minus 4. So I'm going to write it in parentheses, and this way I'm multiplying the whole side by y. All right? So rewind that if you need to see it again in slow motion. I'm going to cancel out these y's on the right side, and that's going to be 5 equals to y x minus 4. Remember, you're trying to solve for y. Since this is multiplication, probably better that if I don't distribute. So instead, I'm just going to get rid of this x minus 4 by dividing it to both sides. And that way, I can just get rid of these like that. And we get y equals to 5 over x minus 4. I notice that we're starting in function notation. So I'm going to write f inverse of x is equals to 5 over x minus 4. All right, hopefully that's not too bad. I know with some practice, you guys are going to rock the house. Again, rewind if you need to see that parentheses and why I chose not to distribute, okay? All right, let's do more, right? Because these are really good. These are the more difficult ones. You notice we got 2 different x's here, right? And no, we cannot cancel this x and this x, right? We cannot cancel because those are terms, and we can only cancel factors. So how do we want to do this? Well, if we're looking for the inverse function, we're going to start by saying y equals to x minus 2 over x plus 3. Now we're going to swap out the variables. So this is going to become x equals y minus 2 over y plus 3. And then from there, we can go ahead and get this y out of the denominator. So let's multiply y plus 3 to this side. And I don't have enough space, but let's try to multiply it here to this side as well. Okay, so these are going to cancel. And it's really going to leave us with y minus 2 here on the right side. On the left side, I got to decide, do I want to distribute or not? I have some choices, right? If I choose to divide, not distribute, let's say, and divide by x, don't write this down, but let's see. If we divide by x, we'll cancel these out, right? Okay, what I do to one side, I'll have to do it to the other. Look, now we have y's and x's all mixed up together, and, you know, back to square one, right? We're not really so sure how to do that. So we're kind of mixed up here. Let's try to distribute and see if we get anywhere. So when we distribute this one, we're going to get xy and 3 times x, 3x. So I have a y term here and I have a y term here. Let's get our y's together and let's get everything else to the other side. So I'm going to move the y to the left side. All right, let's get those together. So now we got our y's over here. And let's move this 3x to the other side. It doesn't have a y, so we don't want it there. So let's just do it all in the same step. There we go. Boom. Let's rewrite it. This looks like a hot mess, right? We got xy minus y equals, what do we have here? Minus 2 minus 3x, or we can write it as minus 3x minus 2. That looks a little better. All right, now, I notice that these 2 terms have something in common. Let's take the y out that they have in common, which would then leave me with x, and it would leave me with minus 1. Let me bring this over here, negative 3x minus 2. And since now I finally isolated y, all I got to do is divide by this factor here, x minus 1, and then I can cancel it out, right? So if I divide x minus 1 on both sides, I can cancel out this factor, leaving me with y equals this, which means that is equals to your inverse function right there. Okay? So good question, and this was an example of one that we wanted to distribute, okay? All right, question B is just an extra example. If you want to see something like that, you can try that one on your own, okay? Next thing that I would like to cover is the horizontal line test for inverse functions. All right, so I'm going to read to you what it says in blue there. It says a function f has an inverse function if there is no horizontal line that intersects the graph of the function at more than 1 point. At more than 1 point, if, in other words, that function will have an inverse function if the horizontal line doesn't intersect it at more than 1 point. Okay, so let's try this out. If I draw a bunch of horizontal lines here, how many times are we going to touch? And the answer to that is 1 time, right? So again, a function f has an inverse function, has an inverse, right? We'll call f inverse, right? If there is no horizontal line, so in other words, don't test it here or here. Test it every possibility, okay? If there is no horizontal line that intersects the graph at more than 1 point. So 2 points already means no inverse function. So as I draw a bunch of horizontal lines here, I notice that it's only ever going to touch 1 point. And that tells me that this function has an inverse function. Okay, that's what that tells me. However, this next one, if I draw my horizontal line right here by the vertex, it's only going to touch 1 point. But again, has no horizontal line ever. So, but what if I draw it here? If I draw my horizontal line right here, I'm going to touch 2 points, okay? Which means this one has no inverse function. I hope that that makes sense. It's kind of similar to your vertical line test, except it's a horizontal line test telling you whether or not this function has an inverse function. Okay, question C here. It does not have an inverse function, so no inverse function here. And then over here, yes to inverse function, okay? Let me write here, has an inverse function. All right, so hopefully that makes sense. Let me go to the next slide, and this is going to be the last example that we do here. At some point, I think I lost count of the numbers of my examples, but that's okay. Use the graph of f in this figure to draw the graph of the inverse function. So the way I like to do inverses, to me, I think is the easiest way. Write down your points of inputs and outputs. All right, so let's see. We got -3, -2. We have -1, 0. And then we have 4, 2. Those are the 3 points that we're given, right? I mean, sure, there's other points, but these are the 3 important points, the key points, if you will. Now, when you're going to find the inverse function, all you need to do, if you think about what we did when we were solving, we swapped x and y. And when we swapped x and y, that's what gave us the inverse function. So when you swap your x and y's, you find yourself the inverse function. Swapping these out, we just get -2 and -3. Swapping these out, we just get 0 and -1. Swapping these out, 2 and 4. All right, let's plot our new points. Well, if we were to plot these points here, let's see, -2 and -3 would be somewhere down here. Then we have 0 and -1. And then we have 2, 4. All right, let's also connect them, right? Why not? There it is. Okay, awesome. All right, so I got my graph there. I hope everybody can see it. And you might notice that there's a little bit of symmetry happening here, right? There is actually a little bit of symmetry occurring. And the symmetry here will always happen at the line of y equals x. All right, that's always going to be where we have a little bit of symmetry. The line of y equals x. Let's see if I can select a pen here and make it kind of thin. All right, so the line of y equals x is when x is 0, y is 0, right? Okay, when x is 1, y is 1. When x is 2, y is 2. When x is 3, y is 3. And you get the idea, right? So we get a little bit of symmetry here along this line. Looks something like this. And of course, the negatives as well. Okay, and then that's why we end up getting a graph that kind of sort of looks symmetrical there. All right, not exactly to an x or y axis, but to this line here, y equals x. We call it the identity function, by the way. All right, I hope that was informative. I hope you guys have a good understanding of lesson 2.8, and enjoy your assignment.